Hi, this is Mrs. Kidman, and in this video, we are going to be discussing the difference between even and odd functions. Now, even and odd functions are not necessarily about the degree of the polynomial, which is what a lot of people think, but it's actually about what the polynomial looks like. So even and odd functions have two special characteristics. One of them is if it's an even function, then we know that this function is even, If this is an even function here, there's two things about it that are special. First, if I put in negative x into my function, then my output is going to give me the same thing that I had originally. So that means if I had something like x squared plus 3x plus 6, and I put a negative x in there, just like this, if my whole thing ends up equaling the exact same thing that I had before, so if this ends up equaling x squared plus 3x plus 6, then it's an even function. The other thing we look for is an even function is symmetric across the y-axis. So what that means is if I'm looking at the graph of it, here's my axis, here's my grid right here. An even function is going to be symmetric on either side of it. So it looks exactly the same on either side of that y-axis. If a function is an odd function has two similar properties. With an odd function, if I put in f of negative x in there, what I'm expecting to get out is the negative version of f of x. So what that means is if I put in a negative x into a function, I'm going to end up getting negative times whatever my original f of x function is. So all of those x's are going to be negative. And the graph here, if we graph it, it is going to be symmetric about the origin or across the origin. So what that means is, remember, our origin is this center point here on our graph. And so something that is symmetric about the origin generally looks the same after we reflect it across the x-axis and then the y-axis. So if this is my axis here, here's a function. If something is symmetric across the origin, that means that it's going to reflect across this axis. So it's going to look like this, and then it'll reflect across that one. So our function is going to look something like this. Do you see how it looks like it reflected across both of those, or kind of diagonally reflected? That's what we're talking about. So in this video, we're going to look and determine whether or not a function is even or odd, or if it doesn't do either of these two things, then we actually say that it is neither even nor odd. So let's take a look. So we wanted to determine whether it's even, odd, or neither. So remember, if it's even, then if I put in a negative x, I'm going to get the same thing. I'm going to get my original thing back out, f of x. If it's odd, if I put in a negative x, then my whole function is going to be the negative version of what it was before. If it's neither, then it doesn't do one of those two things. So let's check out this first one. F of x equals 2x. So I want to substitute in a negative x in there, and then I get 2 times negative x, and that equals a negative 2x. Notice how this is the negative version of our original one. So that means that this function is odd. If we were to graph this function, we would see that it would look like this. And so if we take it right here at our origin point, we would see that it actually does reflect across our x-axis and then across our y-axis. So that function there is an odd function because it looks like this. Reflects. Now, what happens if we substitute it in to this next one? So I'm going to substitute in that negative x there, and we end up getting negative x squared minus 2. Well, negative x times negative x is just a positive x squared. So positive x squared equals negative 2. And that is what happens when we put in a negative x. So I want you to look, this equation here and this equation up here, notice how they're the same. If they're the same after I substitute in that negative x, then this function is, if we can write here, is an even function. And we can tell because it just means that it's reflected across that y-axis. And when we graph one that looks like this is actually going to look like this as a parabola. And this parabola here does reflect right across that axis. Now, let's look at this last one. So I want to substitute in a negative x here. So h of negative x equals 2 times negative x squared plus negative x minus 2. So we want to simplify this. Negative x squared is x squared, so we get 2x squared minus x minus 2. Now let's take a look at this one. This is not the negative version of our original one, because the negative version would look like this, negative 2, it would look like this, negative 2x squared minus x plus 2. So it's not the negative version of it, so it's not odd. And it doesn't look exactly the same, so it's not even because the sign on our x changed. So this last one is actually going to be neither, because notice how it didn't all turn negative or stay the same. And so that's kind of how we determine whether it's even or odd. And then when we graph this, we would see that same situation occurs. So what I want you to do is take the chance to determine whether or not these functions are even, odd, or neither. And we're going to do those by having you practice them on your own. When you finish, unpause the video and we'll go over them together. So start on number 1 here. Pause the video, go over it, work it out. When you finish, unpause the video and we'll talk about the solution. Okay, hopefully you've had a chance to look at that first one. As you look at that first one, you can see that this is actually going to end up being an odd function for us. And the reason why is as I substitute in that negative x, I end up getting out a negative 5x. And that is the definition of what happens when I have a odd function. And we can also tell that when we graph it, that it looks like it is symmetric across that origin, right? It reflects across the y-axis, or across the x-axis, the y-axis, yep. And this is what it would look like. And then if we reflected across our x-axis, it would look just like it does. So we know that this function is odd. Okay, I want you to take a second and do number 2 and number 3 for those next 2 examples. When you finish, unpause the video and we can go over them together. Okay, hopefully you've had a chance to go over those last 2 problems. As you can see, one of them turned out as being neither, and the other one turned out as being even. And we can kind of see what happens here. So in this one, the second one, our original function looks kind of like this. It's this red line. This 2 to the x power is called an exponential function. So it gets exponentially bigger, or it gets bigger as we go. Then the other one turned into a negative exponential function. Notice how neither of these 2 functions are symmetric about the y-axis. They're also not symmetric about the origin. Therefore, we know that it's going to be neither. And these 2 equations are not the same, nor is it the negative version. If we had the negative version of this original one, we would be looking for negative 2 to the power of x. And that's not what we got. Now in number 3, it ended up being even. And we can see that because we substituted in our negative x. And negative x squared is still our x squared, and we ended up with 2x squared plus 3. And that is exactly the same polynomial as what we had up here. So we know that this is going to be an even function. And as we graph it, we can see that it's symmetric across that y-axis. Therefore, to determine if it's even, odd, or neither, we can either look at the equations here, substitute in negative x, and see what happens. Or we can graph it and see whether or not it's symmetric, either across the origin or across our y-axis. And that's how we decide if a function is either even or odd. And if it's not one of those, then it's going to be neither. Generally, the majority of functions are neither, but we do have these certain cases when they are odd or even functions, and we really enjoy having those.